Okay, welcome back everybody. Today we're going to continue with our solving of quadratic problems. And we're going to be making use of either our factoring methods or the quadratic formula in order to get our final answer. So basically there's a strategy or a process we follow whenever we're given a word problem. And the word problems are typically classified under certain types, and you're going to get to see the same type over and over and over again, whether it's a projectile motion, a revenue, a population question, a geometric question, and so forth. We're going to try each type so that when you encounter a similar type in the future, you'll know what to do. So the first thing you do is always read the question carefully. Underline key numbers. Sometimes you're given numbers that aren't important in the question. Sometimes you're given the actual equation. Sometimes you're not, and you have to develop the equation yourself. But make sure you understand what it is that you're looking for. That will help you then introduce your variable. So if you're not given the equation, then you have to create the quadratic from scratch, which means you need to introduce some letters. So that's where that comes in. And then you set up your quadratic. In order to solve the quadratic, remember what you're being asked for there are basically the X intercepts. So that's where you have to make it equal 0. After you make it equal 0 on one side, because it may not equal 0 from the start, you may have to move numbers around. Once you get 0 on one side of the equal sign, that's when then you can factor or use a quadratic formula. If the numbers are easy and small, you try to factor it. If they're decimals or it's not factorable, you have no choice but to use the quadratic formula. Then, of course, after you've actually solved, remember that the math doesn't understand what the question was about. The math will sometimes give you answers that aren't applicable or actually useful in the actual answer. So we call those inadmissible or extraneous, extra. They're like extra answers, extra roots that make sense in the math situation, but not in the context of the situation. Such as if you were trying to find a length and a width to something, so the dimensions of something, negative numbers wouldn't make sense in that context, right? You can't have negative distances. So you would disqualify the negative answer and only accept the positive answers. So take that into account when you write your closing final answer statement, your therefore statement, that you only accept answers that actually make sense in the context of the situation. All right, so let's actually give this a try by going through a couple of them. So the first type is a population question. Okay, so that's the type of question this is. And they give us the actual equation. So this is the type of question where they give you the quadratic to start with. And we know it's quadratic because the x value, which is now called t, is squared. The p, sitting in the y spot, is the population in terms of thousands of people. And t is the number of years after 2000. Now that's key. T isn't year. So if you see t equals 1, it doesn't mean year 1. It means 1 year after the year 2000. So when we have these kinds of questions, we have to have a starting point, an arbitrary start point. In this case, the start point was the year 2000. So 2005 would be 5 years after 2000. So you would sub in the number 5, for instance. Don't sub in 2005. You sub in the number of years after 2000. So what was the population in 2000? So what this question is really asking us is, what was the initial population? So what is the initial population is another way of asking you the same question. Another way of saying it is, what is the y-intercept? So I want you to get used to understanding that there's different ways of asking you the same thing. Since the year 2000 was the start point, and it's asking us for that start point, it wants to know if 0 years have gone by, this is the year 2000 right here. Okay, so that's what that is asking us for. It wants to know where on the population scale were we to start with. So you have two options. If you are in standard form, then you should know by now it is your C value. So we are in standard form, right? So C equals 200, therefore 200,000 people. Not 200 people, 200,000, because it's in terms of thousands. The other option was this always works, it doesn't matter what form you are in, let t equal 0, just like let x equal 0 when you go for the y-intercept. So p equals 0.5 times 0 squared plus 10 times 0 plus 200, you're going to get 0 plus 0 plus 200, which is 200 again, so 200,000. So we're going to end up with 200 as our starting. And remember, this is in thousands, so here's 200. That's our starting point. Okay, what was the population in 1994? Now, 1994 was 6 years, right, less than 2000, or yeah. So therefore, t equals -6. So we want the scale like over here. We're interested in this point. We're interested in what was the population at that point in time. So we have to sub in -6, and it's negative because we went back in time. If, again, remember, time 0 was just set to be the year 2000. So if you're before 2000, then you're negative. If you're after 2000, you're positive. So p equals 0.5, and then you put in a -6 where the t is, you square it, plus 10 times -6 plus 200. We got to work this out. So -6 squared is 36. 36 times 0.5 is obviously 18. Take away 60 here, plus 200. So 18 minus 60 plus 200, we got 158. So remember, 158,000 people in 1994. So 158,000 would be somewhere, say, here. Okay, so this is what was happening to the population graph at that point. Okay, so it was rising to get to 2000, and then it's asking when in the next question. A when is a time, right? So looking for t, not population. Looking for t when the population, so it has to give me a p number, is 462,500. Okay, so it's looking for t when p is worth that. So what we need to do is we need to put our equation down again. And then remember that it gave us the population already with the thousands in it. So this is 462,500 people. So we need to divide that 462,500 by 1,000. So move the decimal place in 3 times to get what you're actually going to sub in, because remember what p is already in terms of thousands. You see how small these numbers are? That's because the thousands has already been divided out of them. So this is really 462.5, right? Jump in 3 times. 1, 2, 3, right there. Jump in 3 times. 462.5. That's the number that goes here, 462.5. Don't use the full number, because the full number has the thousands still in it. Everything else just gets copied down. But remember, we always have to get 0 on one side of the equal sign. So the way we do that is we bring this 462.5 over to put a big fat 0 here, and we collect like terms. So 200 minus 462.5 is -262.5. So now we have the 462.5 incorporated into this quadratic. And what we need to do is we need to solve. right? We're at the point where we're now solving for t. We're trying to find t that makes this equation work. We're looking for the x intercepts. Okay, I want to find these numbers that where we hit this height. That's only going to happen if I solve for t using either factoring or the quadratic formula. Now, I don't want to factor when I see decimals. This would be common factor first, and it could be doable, and then you would aim for simple trinomial. But what if the answers are decimals themselves? You're never going to find them. So I would opt right off the bat without even really trying with the quadratic formula and just do the full quadratic formula to solve for t. So instead of x equals, because there's no x in this equation, you're going to start with t equals negative b plus or minus the square root of b squared minus 4ac all on top of 2a. So remember, if you're the type of person that needs to physically see it, a equals 0.5. B equals 10. C equals negative 262.5. Those are the numbers that you sub in. I pulled them right out of the equation. So T equals negative 10 plus or minus 10 squared minus 4 times 0.5 times negative 262.5. Always never make it long enough. All over 2 times A, 2 times 0.5. So T equals, let's clean this up. Negative 10 is just negative 10. Half of 2 is 1. That was easy to clean up. This is 100, right? 10 squared. Negative times negative is positive, so that's good. So we know we're going to have roots because this is going to stay a positive number. Half of 4 is 2. So 4 times 0.5 is 2, but we times that by 262, decimal 5. And we get 525. So looks like we're going to actually get some nice numbers. So this might have actually been factorable quite well. So T equals negative 10 plus or minus the square root of 625 all over 1. So T equals negative 10 plus or minus the square root of 625 is 25. 25 times 25. And you don't have to put it on top of 1. You can if you want, but it doesn't really do anything, remember, when you divide by 1. So we get our two answers here. So we go T equals negative 10 plus 25. T equals negative 10 minus 25. So 25 minus 10 is 15. Negative 10 minus 25 is negative 35. So this question is now going to give us two answers, but do these both make sense? So remember, this is 15 years after 2000. So this is 2015. This means 35 years before 2000. So this is the year 1965. Those are the 2 years it gave us where we're going to reach this height. Well, we can tell from our graph, negative 35 would be over here. Doesn't make sense. We're already at 200 here. So at 15, we'll be where we want to be. So it's going to keep increasing like that. So 2015 is the one that we accept because this one is way too far back in time. And just from the graph, we can see that it's not accurate. So don't forget your therefore statement. So therefore, this city will reach a population of 462,500 in 2015. Okay, so we've answered the question. City will reach a population of 462,500,000 people in the year 2015. So 15 years after 2000. And again, we didn't accept this other answer, even though parabola has two arms, because it's extraneous. It's an extra answer. It already did it in the past according to the math, but we know that's not likely. Okay, but the math didn't know what we were talking about, that we had time on the x-axis. Okay, so that's why it's important for you to always see, both your answers make sense? Sometimes they do, and if they do, then that means you actually report both. If they don't, then they don't, right? You only accept the one that does. Okay, so what do we have here? This is a geometric one. So it says the length of a rectangular backyard pool. So as soon as I read that, automatically I draw it, right? Geometry, draw the shape. The length of a backyard pool is 7 more than twice the width. Okay, that word is, remember, from your linear systems means equals. So the length is 7 more. More means add. Two widths. So it looks like this. The length is 7 more than twice the width. That's what those words told me. Then it says the area. So now it brings up the word area. Area is 102. Find the dimension. So it's asking me to solve for length and width. Okay, so we have length and we have width. So you notice it didn't give me a quadratic in this case. Like it didn't give me the equation. So this is now where we have to start from scratch. So the first thing you do is you say let L represents the length of the pool, and again units. That's what the sentence needs to look like. Let W represent the width of the pool in meters. Make it look like that, please. Second thing we need to do is we need an equation. So our equation now comes from area. It told us the key word was area. And area, as you know, is length times width, which helps us out because we're trying to get a quadratic out of this. And we know that the area of a rectangle is length times width. But we know that also the length, because right now it's 2 different letters, right? We don't like 2 different letters in the same equation. We know that the length can be represented as 2W plus 7, right? 7 more than twice the width. So that means this is the chunk that's going to replace the letter L, just like in linear systems. So instead of calling it L, call it 7 plus 2W, or 2W plus 7. And then you just still times that by the other W. And then, of course, what we naturally feel like doing now is we expand. So I'm writing down on the side here what it is that I'm doing in each step so you guys can follow along. So 2W times a W is 2W squared. 7 times a W is 7W. There we go. So that's expanded form. That looks like a quadratic. Notice there's no more L's anymore, which is good. We like that. We don't want L's and W's mixed together. In the end, we can find L out as soon as we figure out what W is first. But we know that the area is equal to 102. So wherever you see the area, replace it with 102. But we don't solve equations when they're equal to random numbers like 102. So now we have to make it equal to 0, right? We have to set the equation to equal 0, which means the 102 is going to go to the other side where everybody else is sitting, and we're going to get a big fat 0 where he used to be. There you go. So now you're looking at a nice standard form quadratic. So your options now are to solve, because we're trying to solve for W, right? So you can solve via factoring or the quadratic formula. So we try to factor first. I like 2, I like 102, but I don't like the 7. The 7 ruined it, because otherwise I could pull out the 2. If I do decomposition, 102 times 2 is 204. Do I know numbers that multiply to 204 and add to 7? I can try on my calculator. 204 divided by 12, 12 and 17, 204 divided by 8. No. 204 divided by 16. No. 204 divided by 13. 204 divided by 17. Ooh, 17 and 12 is 5 difference. Okay, so we're getting close. 204 divided by 18. 204 divided by 19. 204 divided by 21. No. 204 divided by 22. No. 204 divided by 23. So you can see that this 24 and 8.5 now. So factoring is looking like it's going to take me a while to try and figure out numbers that might work. So I might just opt for the quadratic formula. So W equals, again, it starts with W equals because there's no X in this equation. We're looking for the W intercepts. So again, if you're picturing a graph, it's W on the X-axis, area on the Y-axis. This is a parabola that opens up. So we're looking for something like this, right? We're looking for these two guys, those two numbers, those X intercepts, which are now called W intercepts because it represents width. So negative b plus or minus the square root of b squared minus 4ac all over 2a. So b is 7. So 7 squared minus 4 times 2 times negative 102. And again, you can write out your ABCs on the side if it helps you out. Negative 7 plus minus 49 in the front, positive 8 times 102. So positive 816 in the back there, all over 4. Notice again, it's all over. Don't just put the 4 under the back section. So 816 plus 49 is the next part. I have to figure out what those two things added together. So negative 7 plus minus the square root of 865 all over 2 times 2, which was 4. So I need to square root 865. And yes, decimals make sense here. We're talking about distances. Distances can be decimals, just like money can have decimals. So I get 29.4. So negative 7 plus or minus 29.410888234 all over 4. I don't feel comfortable just calling it 29, and I don't feel comfortable even in calling 29.4, although you're probably still going to be in the right area if you do. I'm going to keep all my numbers for now because it might make a decimal place difference. So this is why we couldn't factor it, because the answers are going to be decimals. So we have our two answers for W. Negative 7 plus this 29 number divided by 4. Negative 7 minus this 29 number divided by 4. So negative 7 plus 29.4. And then we divide by 4. So the first answer I get is 5.6. Negative 7 minus 29.410888234. And then we divide by 4, negative 9.1. So again, remembering that W stands for width. Width is a distance, right? If you go back to our diagram, it's this amount. This amount cannot be negative 9 meters. That doesn't make sense. Negatives do not make sense. So the math doesn't know that because the math is giving us the two answers from the graph. So this is what we call inadmissible or extraneous. Extraneous means that it's an extra answer, but we're not going to accept it. We're only going to accept the answer that actually makes sense. So this is the acceptable one in the context of dimensions. So now that we know what our W is, therefore, the width of the pool is 5.6 meters, and the length, because it wants full dimensions, will be L equals 2 times 5.6 plus 7, right? 2 W's plus a 7. So add 2 W's together, and then add 7. So 18.2. So there's our length and our width, and 1 decimal place is fine in your final answer, unless you're told otherwise. Okay, so that's why we couldn't accept this other answer, because it didn't make sense. And also I'm showing you not to waste your time trying to factor something. If you can't find the numbers right away, go straight to the quadratic formula so you're not wasting time on a test or a quiz. Here's another one. But this one is what I call sort of the frame border question. So these type of questions are very, very different. So it starts off the same. We're back to a rectangular pool is 10 by 5 meters. So draw yourself a rectangle. Okay, so 10 meters by 5 meters. Okay, so here's our pool. That was step 1. It's to have a deck. Now, a deck could be a sidewalk, a walkway, whatever you want to call it. Basically, a border is going to go around it. Uniform width means same all around. That's what it means. So the amount that is over here is the same amount that's over here, which is the same amount that's over there, which is the same amount that's over there. So if the area of the pool is equal to the area of the deck, how wide is the deck to 1 decimal place? So we don't know how wide this needs to be. So from there to there, we don't know how the width of that thing. That's what it's asking us to find. But we do know that it's the same all around. So this distance is x, this distance is x, even though it doesn't look it on my diagram, it is. This distance is x, this distance is x, this distance is x. I picked x. You could have called it W for width, whatever you want to call it. I'm going to use the letter x. So it's the same all the way around. So again, step 1, let x represent the uniform width. How wide is the deck? Of the deck. Again, units would be meters. So there's my let statement. Now the only hard thing about this question is now I have to come up with a quadratic. The quadratic wasn't given to me. So this is now where I want you to pay attention to amounts. If this is 10, from here to here, right, the pool itself is 10. If I add an x on this side and add an x on this side, right, that means the whole distance from the edge to the edge is going to be 10 plus an x plus an x. So the whole thing will be 10 plus 2 x's all the way. And likewise, going up and down, the whole thing widthwise will be 5 plus an x plus an x. Don't put the meters part. So 5 plus 2 x's. So why do I want to do that? That's because of the next part where it says the area of the pool. Okay, we know that the area, so capital A for area, of the pool is equal to the area of the deck. So capital area, and then I'm just going to write deck. These are called subscripts. They're written below the capital letter there. So this is setting up my equation for me. I just have to fill in what is the area of the pool. I just have to fill in what is the area of the deck and make them equal to each other. So the area of the pool is easy, right? It's 10 times 5, right? Length times width. But the area of the deck, not so straightforward, because the area of the deck is just the border. So again, deck is this part. So if I only want this border part, because that's the deck, remember this is water, that's not decking, I can't just find the area of the border. I have to do total area minus out the stuff on the inside I don't want. This is like those shaded area geometry questions from elementary school, where you have to do the whole area, subtract out the part that you don't want, and that's going to leave you with just the part you do want. So area of the deck is going to be broken down to area total minus out area pool. Okay, so the whole area, the big rectangle, minus out the inside rectangle. So 10 times 5 is 50. Area total is 10 plus 2x times, right, length times width, 5 plus 2x. So that's the total rectangle, minus out the inside, 10 by 5. And there we go. That starts off our quadratic. So that's how you get a border, a frame, without having to have the inside included. So of course what we have to do is we need to expand and simplify. That would be what you would do next, right? We are going to expand this out, collect everything, and then of course you're going to make it equal to 0, just like you have been doing. So 10 times 5 is 50, 10 times 2x is 20x's, 2x times 5 is 10x, 2x times 2x is 4x squared, and then we're going to have to go minus 50 at the back. So this 50 and this 50 are basically going to cancel each other out. I'm going to bring the 4x squared to the front. 20x and 10x makes 30x. And then, of course, like I said, kick that out and get a big fat 0 on one side. There we go. There's our quadratic. So now that you're at the quadratic stage, solve. Solve for x, using the methods that you know. So either you're going to factor. 4 doesn't go into 30 and 4 doesn't go into 50. So this would be a decomposition question. 4 times 50 is 200. Okay, so our AC product, 4 times negative 50, right? First times last. We have to use decomposition because the 4 is still stuck there. So this is negative 200. Numbers that multiply to 200 but give you 30, 10 times 20. The signs are going to be different. The bigger number gets to be plus. No, that doesn't give you 30. So it's not 10 and 20. No, that doesn't work. No. It does give you 200, but it doesn't give you 30 when you put them together. So let's keep trying. Does something else give you 200? So 2 times 100, 4 times 50, obviously. They have to be closer together. What's 200 divided by 15? No. 200 divided by 12? No. 200 divided by 14? No. 200 divided by 16? No. 200 divided by 18? No. 200 divided by 19? No. 200 divided by 22? So you can see that this is a little tedious trying to come up with the numbers. 200 divided by 25, 25 and 8 gives you close, but it's not factorable. It doesn't seem like it's factorable. So I would question, is it even factorable? I can't seem to come up with numbers that work. So I would just use the quadratic formula. Again, unless the numbers are obvious, and because this is a dimension question again, it told us to 1 decimal place right in the question. So keep your answer to 1 decimal place. That was a clue that we're going to get a decimal as an answer. So again, x equals now, because that's the letter we used, negative b plus minus the square root of b squared minus 4ac all over 2a. So b is 30. 30 squared minus 4 times 4 times negative 50. Going to work that out. All over 2 times 4 at the bottom. Okay. 30 squared is 900. Negative is a positive, which is good. 16 times 50, 800. So that's 1700 under there, all over 8. So negative 30 plus minus the square root of 1700, all over 8. So again, we have to figure out what the square root of 1700 is. Keep it as accurate as you can. So negative 30, going to do this in one step if you want. Negative 30 plus the square root of 1700 divided by 8. X equals negative 30 minus the square root of 1700 divided by 8. This is how we're going to get two answers out of this guy. Doesn't mean both answers are going to make sense. So negative 30 plus root 1700 equals, divide that answer by 8, and we get 1.4. Negative 30, take away the square root of square root of 1700 equals, when you divide that by 8, you get negative 8.9. So again, this is extraneous. The distance around the pool can't be negative 8.9 meters. Again, it doesn't make sense. So this is the one that we accept. So because again, we're talking distances and you can't have negative distances, we then say therefore, the width of the deck is, to one decimal place, 1.4 meters wide. Done. We've answered the question. Again, we can't accept every answer just because the math tells us. The math will give us two answers because it doesn't know what we're talking about. Okay, so we only accept the one that is the positive case. And again, showing you the quadratic formula was the only option here because it was a decimal. It wasn't even factorable. So we're not going to waste our time trying to factor something that's not factorable. Okay, so you've just seen two sort of geometric questions and a population question. This one is a money question. The volunteers at a food bank are arranging a concert to raise money. They have to pay a set fee, right? They have to pay the musicians, plus an additional fee to the concert hall for each person attending. The relationship, so it gave us the quadratic. So this one, they're giving us the equation. Models the profit, P in dollars. So on one axis, this is profit in dollars. So not thousands of dollars, just regular dollars. For the concert where N is the number of tickets sold. Number of tickets sold is here, and that's the N. So we have P and we have N, and those came to us in the question, so we don't introduce them. So this is what the graph would look like. Calculate the number of tickets they must sell to break even. So the keywords were break even. Break even is a fancy way of saying no profit, i.e. profit equals 0. Remember, profit is extra money. It's after you've paid off all the costs. It's the extra money that stays in your pocket. You'll break even when you've paid off all of that, but you don't have anything extra. As soon as you have anything extra, then you're making profit. That's not break even anymore. So what we're being asked to do is solve for the X intercepts, right? Which in this case is the N intercepts. We're looking for where does this parabola hit the N axis. So he opens upside down and he has a y-intercept down here. So something like this. He goes up and he comes down. So I'm interested in these two numbers. What are they going to be? Okay, so I know he opens down because it's a negative in the front, and I knew that the y-intercept was negative 48,000. So down here. So they sell 0 tickets. They spent $48,000. They're $48,000 in the hole at 0 tickets sold. So obviously they need to start selling tickets. So P equals negative N squared plus 580N minus 48,000. So what you can do is you can try to factor, but I'm going to use the quadratic formula right off the bat because the numbers are large. So n equals, and again it's n equals, not x equals, because there's no x, negative b plus or minus the square root of b squared minus 4ac all over 2a, negative 580 plus minus 580 squared, minus 4 times, the a value is negative 1, times the c value, which is negative 48,000, all over 2 times negative 1. So we got to work this out, negative 580 in the front. So 580 squared is a big number, thank God, 336,400. A negative times a negative times a negative is a negative. 4 times 1 is 4. 4 times this 48,000 number is 192,000 in the back, all over negative 2. Again, n equals negative 580 plus minus 336,400 in the front minus 192,000 in the back, 144,400. I think that's a good number, all over negative 2. When we square root this, you get 380. So when you square root 144,400, you get 380. So that's a very nice number. So plus minus 380, no decimals, all over negative 2. Now keep in mind, you can't sell a decimal of a ticket. You either sell 20 tickets or 21 tickets. You don't sell 20.2 tickets, right? So decimals do not make sense in this context. So what do we have? Let's figure out our n numbers. N equals negative 580 plus this 380 number divided by negative 2. N equals negative 580 minus this 380 number divided by negative 2. All right, so negative 580 plus 380, okay, divided by negative 2 is 100. And the other one, negative 580 minus 380 divided by negative 2 is 480. So, based on our graph, at 100 tickets, they break even, and at 480 tickets, they cover their costs. Because remember, the more people that come, the more actually they end up spending on the venue itself. So this is the minimum that they should sell, but this is the maximum they should sell. They shouldn't go over this because then, look, they start losing money again. The profit ends up in the negatives. You don't want to be in the negatives. So they need to cap it. And obviously the sweet spot is right in the middle, right? We want to be in the middle to make the most money. So both of these answers make sense. So calculate the number of tickets they must sell to break even. So therefore, to break even, they should sell either, because it's both, 100 tickets or 480 tickets. So if they're looking to not make any money, they need to sell either of those two numbers. If they're looking to make money, anywhere in here, they make money. You want to be somewhere in there. So there's obviously better spots, right? Because here we're at positive profit, positive profit, positive profit, positive profit, positive profit, maximum profit. They want to be up here. That's the sweet spot. You want to make the most money possible, which means you have to figure out how many tickets should you sell. Well, that's the axis of symmetry, isn't it? Determine the number of tickets they must sell to maximize profit. So we need the vertex. And more specifically, the X value of the vertex, right? We need to know just the ticket number. It didn't ask us for what the maximum profit's going to be. We just need to know what is the X value of the vertex. But we just found our X1 and our X2, right? Our S and our T. So 100 plus 480 cut in half. Where's the middle? So this is 580 divided by 2. And what do you get when you divide that by 2? 290. Therefore, they reach max profit when they sell 290 tickets. So that's when they will be at their peak. Okay, so at 290 tickets, which is the middle of the two X intercepts that we just found, smack dab in the middle, which is the axis of symmetry. It didn't ask us what the maximum profit will be. If it did ask us that, then we would need the rest of the vertex. We would have to sub in 290 to get the rest, or just find the vertex using completing the square. Either way, you're going to get 290 tickets as the best option. All right, so again, the more you do of these, definitely the more repetition, the more comfortable you become, because they all start sounding very much the same. All right, until next time.